All right, let's dive in. We are right in the middle of what might be one of the biggest leaps in technology ever. I'm talking about the humanoid robot revolution. For years, they've basically been science fiction, right? But now, thanks to some mind-blowing breakthroughs in AI and engineering, they are literally stepping out of the lab and into our world. So, let's unpack this. The incredible new brains powering these machines, the surprising flaws in their bodies, and the huge questions we all need to start asking.
And this quote from Nvidia's CEO Jensen Huang, it just nails it, doesn't it? This isn't just about building a better gadget. This is about tackling one of the grand challenges of artificial intelligence, creating a robot that can actually think, learn, and operate in a world that was built for us.
So, what is the big breakthrough that's making all this happen right now? Well, it all starts with the brain. We're finally moving beyond those single-task robots you see in factories and into a whole new era of generalist AI. We're talking about AIs that can learn and adapt to almost anything you throw at them.
At the absolute heart of this is Nvidia's Project GR00T. It's built on what's called a foundation model. The easiest way to think about this is like a starter brain for the robot. Instead of having to program a robot for every single possible task, GR00T gives it a general intelligence. It can understand language and, get this, learn new skills just by watching a person do them.
And that's really the core of this whole revolution. Just imagine for a second, what if a robot could learn how to fold laundry, or sort packages, or even assist in a hospital? Not because someone wrote a million lines of code for each action, but because it just watched a video of a person doing it and figured it out. That's the incredible power of imitation learning.
So how does it actually work? Well, the GR00T model kind of borrows an idea from human psychology. It has a two-part brain. You've got System 2, which is the slow, deliberate planner. It hears a command like, "Bring me water," and it figures out all the high-level steps. But then you have System 1. That's the fast, reactive, gut instinct part. It manages all the tiny, subconscious movements needed to stay balanced, grip the glass just right, and walk without tripping. It's this combination that makes the robot's motion look so fluid and intelligent.
But here's the problem. Teaching a robot in the real world is incredibly slow, it's expensive, and honestly, it can be pretty dangerous. That's why the vast majority of this learning now happens in simulation. Using virtual worlds like Nvidia's Isaac Lab, developers can run millions and millions of tests, exposing the AI to everything from a slippery floor to a cluttered room, letting it learn safely and, of course, exponentially faster.
Okay, so the brain is getting super smart. But that leads us to a really critical question. What about the body? Because some experts are starting to think the entire industry might be overlooking a fundamental hidden flaw in how these things are being designed.
I mean, really think about it. Is a powerful brain actually enough? If you put a supercomputer inside a clunky, inefficient body, do you really have an intelligent machine? Or do you just have a very smart, very fragile puppet that's going to run out of battery?
Let's just look at the raw data for a second. To take a simple walk, the Tesla Optimus robot burns through about 500 watts of power. A human, doing a much more demanding, brisk walk, uses only around 310 watts. That means the robot is almost 45% less efficient. This energy problem is a massive hurdle because it limits how long these robots can even operate before they need to be recharged.
And this quote just brilliantly sums up the problem. A robot like Optimus can be shown folding a shirt perfectly, but it's relying on its powerful brain to meticulously plan every single movement. It completely lacks a human's simple sense of touch. Its rigid hands would be totally stumped by something as unpredictable as a crumpled shirt on a messy bed.
So what's the solution? It's a really cool concept called mechanical intelligence. The idea is that the body itself should be smart. Think about how a pine cone scales open up in the dry air to release seeds. That's a purely physical reaction, no brain needed. The goal is to build robots with smarter bodies that are naturally efficient so the AI brain can focus on the big picture, not on micromanaging every tiny little movement.
So even with all these challenges, the race is absolutely on. Why? Because the economic potential here is just staggering, and it's fueling a massive global market.
Okay, get ready for this number. Goldman Sachs projects that the humanoid robot market is going to hit $38 billion by 2035. And get this, that's over 6 times higher than what they were forecasting just 1 year ago. That kind of insane acceleration is what's lighting a fire under this whole industry.
And you can see exactly why things are exploding when you look at these two powerful forces. First, the cost to actually build these things is dropping like a rock, down by about 40% in just 1 year. And at the exact same time, the market forecast has gone through the roof.
cheaper robots, and a way bigger market, that creates a feedback loop that's pushing us straight toward mass production.
So where are we going to see them first? Well, the initial jobs will probably be in structured places, like manufacturing plants and warehouses. But they're especially perfect for all those jobs that are, dangerous, dirty, and just plain dull for humans to do. Things like disaster rescue, mining, or maintaining nuclear reactors.
But as these machines get ready to step out of the workplace and into our lives, maybe even our homes, we have to stop and confront some really profound ethical questions. Because this technology isn't just about code and gears anymore. It's about our society.
So, what are people most worried about? Well, the data is overwhelming. A recent survey shows that a full 90% of people said privacy was a top concern. Right behind it, 85% pointed to safety. I mean, it makes sense, right? These robots will be packed with advanced sensors and cameras, and the public is making it very clear they want strong safeguards in place.
And the concerns get even more personal. When people were asked if humanoids should be used as caregivers for the elderly or for children, the hesitation is really obvious. A combined 45% of people flat out disagree with the idea, and only about 30% are on board. We're just not quite ready to hand over these deeply human roles.
And what about control? This is the big one. A staggering 80% of the public believes these robots should have either limited autonomy with significant human oversight or no autonomy at all. The message here could not be clearer. Society wants a human in the loop. We are not comfortable with fully independent machines making their own decisions while walking around us.
So all of this brings us to the ultimate question. The technology is moving forward at lightning speed, but as a society, are we really ready for what's coming next?
The path forward is basically a series of critical trade-offs. Technologically, it's this choice between racing ahead with the AI brain versus taking the time to build a truly efficient physical body. Economically, we have to balance the huge boost in productivity against potential job displacement. And socially, for all of us, it's a constant tug-of-war between the convenience these robots offer and our fundamental rights to privacy and safety.
In the end, the humanoid robot is really just a mirror. It's reflecting our own values, our priorities, and, our fears. The technical challenges of building them are obviously immense, but maybe the greater challenge is deciding what we want them to be. Because as we design their brains and their bodies, we're also defining our own future. And what we decide is going to say an awful lot about who we are.